In this section, we'll talk about the three-dimensional line integrals. Suppose that we have a smooth space curve C, where smooth means a curve that has a continuous and non-zero tangent vector, and that curve is given by the vector equation r of t that is equal to x of t times the vector I, plus y of t times the vector j, plus z of t times the vector k. And we also have a three-variable function f of x comma y comma z that is continuous on the curve C. Then the line integral along the curve C of the function f of x comma y comma z times ds will be equal to the integral from a up to b, where a and b are the bounds of t, of f, and now x, y, and z are expressed as a function of t, times the square root of dx over dt to the square plus dy over dt to the square plus dz over dt to the square times dt. So in short, the line integral along the curve C of the function f of x comma y comma z times ds is equal to the integral from a up to b of the function f evaluated at the vector equation of the curve, vector r of t, times the magnitude of the tangent vector times dt. Let us see an example about that. We're asked to evaluate the line integral along the curve C of x times y times z times ds, where the curve C is given by the parametric equations x equals to 2 sine t, y equals to t, and z equals to negative cosine t, where 0 is less or equal to t, less or equal to pi. We'll need to use the dx over dt, dy over dt, and dz over dt, so we'll evaluate them now. So since x is equal to 2 sine t, dx over dt will be equal to 2 cosine t. And since y equals to t, dy over dt will be equal to 1. And since z equals negative 2 cosine t, dz over dt will be equal to 2 sine t. Therefore, the line integral along the curve C of x times y times z times ds will be equal to the line integral along the curve C of x times y times z, and ds is equal to the square root of dx over dt to the square, plus dy over dt to the square, plus dz over dt to the square, times dt. So this is equal, and we now convert everything to the parameter t. So we have the integral from 0 up to pi for t. X is equal to 2 sine t, y is equal to t, and z is equal to negative 2 cosine t. And then we have the square root of dx over dt to the square, which is equal to 2 cosine t to the square, plus dy over dt to the square, which is equal to 1 to the square, so 1, plus dz over dt to the square, which is equal to 2 sine t to the square, times dt. So that is equal, and we can pull out a negative 4 from 2 times negative 2. So we have a negative 4 times the integral from 0 up to pi of t times sine t times cosine t, and then the square root. From the square root, we have the square root of, from the first and third term, we have 4 times cosine squared of t plus sine squared of t, and then plus 1. So that is equal to 4 plus 1, so square root of 5. So we have times the square root of 5 times dt. So this is equal to negative 4 times the square root of 5, which we pull out aside of the integral, and we have the integral from 0 up to pi of t. And then the sine t cosine t, we can write that as 1/2 sine 2t. So times 1/2 sine of 2t dt. So that gives us a negative 2 square root of 5 if we simplify it, times the integral from 0 up to pi of t times sine of 2t. And here we can times dt. And here we can do an integration by parts. So setting u to be equal to t, du is equal to dt, and dv is equal to sine of 2t. So v is equal to negative 1/2 cosine of 2t. We get that we have a negative 2 square root of 5 times, we have a negative 1/2 t times cosine of 2t, evaluated between 0 and pi, minus the integral from 0 up to pi of the negative 1/2 cosine of 2t dt. So that is equal to negative 2 square root of 5. And then we have negative 1/2 pi times the cosine of 2 pi. And then for t equals to 0, we'll have a minus 0. And then we have a plus 1/2. Integral of cosine 2t dt will give us 1/2 sine of 2t. And that needs to be evaluated between 0 and pi. So we have a negative 2 square root of 5. From here, we get a negative pi over 2. And then we have a plus 1/4. And we evaluate the sine 2t. So we'll have a sine of 2 pi minus sine of 0. So that gives us a negative 2 square root of 5. And sine of 2 pi, sine of 0 are equal to 0. So we have a negative pi over 2 that remains. So that gives us that this is equal to the square root of 5 times pi.